Hello everyone. Today we are going to see why a DC motor is called as a DC shunt motor is called a constant flux motor. So to understand this, today we will see why a DC motor is called constant flux motor. To understand this, let me consider the circuit diagram of DC shunt motor. This DC shunt motor is going to have a field winding. There will be a field winding and I will have a armature, and this armature is going to have certain resistance which is represented in series with the armature. So this is the circuit diagram for DC shunt motor. This is the armature and I have this field winding. Okay, so this is the field winding, and we are going to apply the DC voltage across these two terminals. So I will call this terminal as a plus terminal and this terminal as a minus terminal, and this is the DC voltage, and the current flowing in the shunt field winding is called as a ISH, and the current that is flowing in the armature winding is called as a armature current I. Okay, so this is the equivalent circuit. Now what happens when the motor is going to run? This is going to run, okay, by taking this armature current IA and VDC. So if you observe this diagram, this shunt field winding is connected parallel to the DC supply. Okay, so usually how this kind of a DC shunt motor is operated is, in this case we are going to keep this supply voltage VDC constant. This voltage will be kept constant. So in India we are normally going to have 24 volts DC, 12 volts DC, 240, 220 volts DC. Similarly we have 110 volts DC. This voltage which will be kept constant throughout the running of this DC motor. Okay, so and what we will do is, this load on this motor will be continuously changing. Okay, so as the load is going to vary, the current through this armature is going to vary. For example, if there is no load on the motor, that means when the motor is working on no load condition, this current will be small. As you are going to load this motor, this current IA is going to increase. This IA increases as you are going to load the motor. But as you load the motor, what happens to this current ISH? If you observe this diagram, as I told you, whatever the changes you are going to do in this path will not have any effect on this shunt path. Okay, because it is connected parallel with the supply. Until and unless this voltage is constant, this current ISH is going to remain constant irrespective of this loading condition. Okay, so why it is this kind of a thing is, if I just represent it in a circuit diagram, I am going to have a resistor which will be parallel, and similarly I am going to have a resistance, and this armature, this entire branch armature plus this armature resistance will be represented as another resistance which I will call it as RA, and it is variable in nature. As you are going to load the motor, this current is going to change, and that because of that I will represent this entire thing as a variable resistance, and this is fixed. RSH is fixed and you have a voltage VDC applied here. So now what happens, this condition whatever I told now is similar to a condition of varying the rheostat. Initially when motor is working on no load condition, this entire thing will be like a open circuit, so that very small amount of IA is going to flow. And as you are going to load the motor, this resistance is going to come down, and because of which the current here is going to increase. And if you observe this diagram here, what is during this entire process, this ISH is going to remain constant, because this ISH is nothing but V divided by this RSH. Since this VDC is constant, this ISH will also remain constant, because this is fixed, and this RSH we are not varying this RSH, it is kept fixed, because of which this ISH is going to remain constant. And you know that flux is proportional to, in this case this flux is proportional to ISH. Okay, so that is the current flowing through the field winding. And since this ISH is current, throughout this entire operation this flux is going to remain constant. Okay, so hence we call DC shunt motor as constant flux DC motor, constant flux motor. And only in certain areas or wherever the speed changing is required, in that case we are going to vary this VDC. Okay, so for speed control, in that case, because it is connected in parallel, automatically the flux through this winding is also going, flux current through this winding is also going to reduce, and it will have effect on the flux. So I hope you understood the concept. And since the flux is going to remain constant throughout the operation of this DC shunt motor, this DC shunt motor is called as a constant flux motor. Thank you for watching this video.